1.2, the slippery slope of lines, deals with all of the ways that you're going to kind of see lines get dealt with in calculus. And so we're trying to get you used to, what do I do in certain situations? The AP Calculus curriculum really tries to mix things up so that you really understand all the notations and all the ways that they can ask the same kind of question. So first, let's talk about slope. So slope's pretty simple, okay? Slope is represented usually by the term m in algebra, and what you have to do is you have to take one of your y-coordinates minus the other y-coordinate over the difference in your x-coordinates. The key here being that you pick the same set vertically. So, y2, a lot of people say goes first, so x2 has to go right below that. So one way that you can write it is, write the coordinates that way and then write the other coordinates next, because sometimes you might get mixed up. So that's how you find slope if you're given 2 points. Now, how do I find a line? Well, for a line requires 2 things. You need a point, and you need a slope. So, if you have to find the slope, you've already got 2 points. So you just have to pick one of them. And then you have to use the slope together. Now, right below, I'm going to write with the point-slope formula of a line and how that works. So the point-slope formula of a line works as follows. And it doesn't matter which point you use, but it's just going to work like this. Now you're going to have the general y minus its y, like one of your y-coordinates, whatever point you choose. That's going to equal your slope, which is m, times general x minus the x-coordinate that went with your y-coordinate. So this is actually the formula for a line. Now, you can actually go and expand this and find the y-intercept or the slope-intercept form of the line, but technically this is the formula for a line, so you could almost stop there if you want to. Now, one thing that they also ask is, what happens if we have lines where we want to see if they intersect? So let's say we have a couple of equations. Let's say we have, so hold on a second, let me write this down. So if we want to see where they intersect, if you ever want to see where anything intersects, so let's say we have 2 equations. We've got y equals 2x minus 3, and we've got y equals 4x plus 9. So 2 different equations. Now, if they intersect, something has to be true. They're sharing a point, 1 point at some place. So we know that if they intersect, that they have to share an x and they have to share a y. Now, if they're presented in this way, the best thing to do is realize, like, hey, I've got y equals on both sides, so what you can go ahead and say is that this equals that. So you go forward, find this equals that, and that'll tell you what x-coordinate they meet at. Now, if you have the x-coordinate where they meet at, you can go back and find the y-coordinate that they meet at as well, if that's necessary. So just know that once you have the equations, which again, the equations are going to come from up here, right? So like if you need to find your slope, do it this way. If you need to find the equation of the line, take one of those points and your slope and use this equation here. And then if they intersect, take their y equals versions and then set them equal to each other so that you can find where they meet. That's excellent. Moving along. Now, a couple of things that they can throw at you. They can throw at you and say, okay, so, well, what is parallel and what is perpendicular? So, we've already decided that, our slope equals m, okay? So if our slope equals m, then a parallel line will also have a slope equaling m. So if you say that, let's say the slope of this line is 2, and there's a line that's parallel with then we know that line also has a slope of 2. It's perfect, so it's implied there. Now, if it's perpendicular, it means it meets it at a 90-degree angle. That's a little different. So, that means if they say that a line is perpendicular to another one, then that means that the slope is going to be -1 divided by m. So, in an instance that the slope of the original line is 2, and another line is perpendicular to it, its slope would be -1 over 2. So -1/2. It's the negative reciprocal of that. So you'll see that kind of come up a lot too. So just make sure, these are given pieces of information that you're going to be asked to use a lot. So make sure we know what these are. The last thing that kind of comes up here is we're talking about how they do. Sometimes they write things differently. For us. So normally we're used to seeing coordinates, let's say in terms of x1, y1. So we're given us an x coordinate and a y coordinate. Well, function notation works like this. So function notation is, f of x equals y. So that is what we normally see. They're the same thing. If you see f of x is the same thing as saying y. F of x is the output. The input here is your x. So sometimes what they say is they may list something like this. F of 1 equals 2. Well, this implies that there's a point that is 1, 2. Very easy. So that's something to keep in mind. So when you get to a problem and you see something and you're like, I don't know what to do the first thing that you think about, okay? So if I go back through these really quick, if it says slope right now, you need to think that's where slope comes from, okay? So if it doesn't tell you what the slope is, so the slope is m, you find it with this formula right here. So that should be your first thought. Go straight to that, think about that formula, and see what pieces of information fit into that. You may be missing too much, but you probably have enough. Now, what happens if they ask for a line? Well, a line requires two things, a point and a slope. So you need to have those before you can go down to the next part, which is actually finding what the line is. It has parts of it that you need before, just like the slope did. In order to find slope, you need 2 points. So you can't start unless you have that. You need a line, you need a point and a slope. So you need to have that. So if they're talking about intersections, you need to have the lines first. So you see the process. We need the slope, and then we can use the line, and then we can maybe find intersection. They may just hint at something about the slope. So that's where your parallel and perpendicular stuff comes in. So this tells us parallel means something, perpendicular means something. Connect that immediately. And then other times they can display the information differently using function notation. If they say, f of 6 equals 9, that means that you have the coordinate 6, 9. That's you have that point. It can say f of x equals 9, then that means there's a point x, 9. So we just write those things down. But that's how we have to go about this part of the process.